Hello class, welcome to our lesson today about testing a claim, dealing with means today as opposed to proportions like we did in our previous section. Everything we're going to look at today is dealing with sigma is unknown, so that means we don't know the standard deviation of the population. There may be a question or two about population, standard deviation, but really the focus is going to be about when it's unknown. So let's go ahead and get started with what that means. Because of the fact that standard deviation is unknown, we have to use a t-test statistic, not a z-score test statistic. And because of that, we have S instead of sigma because S is the standard deviation of the sample instead of the population. You notice here that this is x bar, so the test statistic is found by taking x bar, which is the sample mean, minus mu, okay, of what we expect to occur, which is whatever our claim is, and then we find the test statistic. You're going to use the t-distribution table that is online or that you've been given a copy of, or it's in your textbook. You're going to use degrees of freedom, n-1 for that. There's also a t-test that we're going to look at on StatCrunch a little bit to make sure that we understand how to find both versions for finding p-values for test statistics dealing with a t-distribution. Okay, the first three questions here are a left, right, and two or double-sided test using your table. So if you have your t-distribution table, you'll probably want to look at that. This says that n is 15, so if n is 15, remember the degrees of freedom is 14, and the test statistic is 2.512. Now the difference with a t-distribution table is they don't give you all the numbers, they just give you the critical value or like cutoff locations. So on the table, I went to degrees of freedom 14, and these are the 5 numbers that are on that line, in that row for degrees of freedom equals 14. Your goal is to figure out where your test statistic falls within this range. So if you start here, it's 2.9, it gets smaller to 2.6, and then 2.1. Well, yours is around 2.5, so it's between the 2.6 and the 2.1. So it's in the middle here between those two things. Then you go to the very top or the bottom of the table, probably the top. And since this is a right-sided test, that's an area of one tail. If it said left or right-sided, that's one tail. If it said two-sided, or that would be area of two tails. So you go to the top and you see that, well, this number would have corresponded to an area of 0.01, and this one would have corresponded to an area of 0.025. So I don't know what the p-value is, but I know my p-value is between 0.01 and 0.025. And knowing that, I don't need to know the specific number to compare that typically with an alpha level. Let's say alpha is 0.05. Well, I know this is less than 0.05 because it's between these two numbers. But you do have to make sure you're looking at the correct one or two-sided piece when you come up with that conclusion. The next thing to look at is a left-sided test. Test statistics typically on left-sided tests are negative. I've got n equals 10, so the degrees of freedom is 9. Here are the 5 numbers for that row. But what you'll notice here is that all the numbers are positive. Well, because of symmetry, we can just assume that if all those numbers are positive for right-sided tests, then all of them would be negative for left-sided tests. So you're just basically seeing, again, which one is it between. So yours is negative 2.1, so that's further than this, further than the second one, further than the third one, but still higher or further away from 0 than the fourth. So it's between the third and fourth numbers. And those areas in one tail, if you look at the top of the table, are 0.025 and 0.5. So that means my p-value is between those two numbers, 0.025 and 0.05. Again, the t-distribution tables are always, they show positive side. Okay, if you have a negative, you just say, well, just pretend they're all negative and see where it's between as well. The next one is a two-sided test where we're trying to find the range. N is 20, so degrees of freedom is 19. I went to the 19 line and wrote down all the numbers here. I'm looking for t equals 1.615. That's between actually the last two, 0.7 and 0.3, so it's in between these two. But when I go up to the top, I have to look at the area of two tails this time because it's a two-sided test. And because of that, my z-score, or I'm sorry, my test statistic for t is between the 0.1 and 0.2, so my p-value is at least 10%, but less than 20%. What this probably means is we're going to fail to reject the null hypothesis. Because the p-value is between 0.1 and 0.2, it's a higher p-value, and so we'll probably fail to reject the null. When you're using your table, you're never going to be able to find the exact p-value. You'll find these range of p-values, and you need to be able to do that on some of your homework questions and for your upcoming tests. So even though we have this test statistic piece we're going to look at with a t-distribution and a t-test from StatCrunch, you also need to be able to deal with this idea. You may find a few questions on your homework that give you a set of data. This happened on your last homework assignment. So a graphing calculator can input a lot of different things. So you'll see mean, this is the sample mean the mean from the null hypothesis because it's mu like sub-zero. X bar is the sample mean, S is the sample standard deviation, N is the sample size. And then you want a not equal to, a less than or greater than t-test, and then you can calculate that. I don't plan on using a whole lot of that version of a t-test idea. Instead, we're going to use StatCrunch to be able to show some of those things. So this one says find the p-value for a right-tailed test with a mean for the mean with an n equals 10 and test statistic t equals 1.425. You have to open StatCrunch, go to Stat Calculator T, and it should open something that looks like this. The key is the bottom. It should be blank in all the spaces here. What you have to do is type in the degrees of freedom. So since n is 10, degrees of freedom is 9. Since this is a right-tailed test, okay, graphically and picture-wise, it should show that it's right-tailed. And you do that by changing this piece right here from a less than to greater than. If it was left-tailed, it'd be less than. If it's right-tailed, it's greater than. And then you type in your test statistic and then hit compute, and it will spit out the answer for you exactly. Compared to the other questions where we have a range of answers, this should spit out exactly what you need for if they ask you for the p-value for this situation. So Stat Calculator T for t-test. You have to type in the degrees of freedom. If it's less than or greater than, you got to change that, and then type in the test statistic, hit compute, and it should spit out the answer that you want. The next one is the left-tailed test with n equals 25, so degrees of freedom is 24. Since it's a left-tailed, I change it to less than. I typed in the test statistic, and it spits out 0.0139. That would reject the null hypothesis if the significance level was, say, 0.05, the alpha level. It would fail to reject if it was 0.01, though. But again, the technology can find that answer for you in terms of finding the test statistic, or using the test statistic to find the p-value. The next question is a two-sided test. The key with a two-sided test is that the test statistic idea only really gives you kind of this less than greater than. You can kind of do the in-between piece, so if you click between, you might be able to kind of process it and figure out how to find that. You can do that if you want. I'm going to tend to use just the less than greater than. So I'm going to find degrees of freedom, and then I do my test statistic. Notice that I could have done greater than 3.104. I chose to do less than negative 3.104 because I know it's a two-sided test. So I can choose either one as long as I do area to the left of the less than or area to the right of the greater than. I get this answer 0.0029, but then I have to double it because it's a two-sided test. So the key there is making sure you double, kind of like the z-score ones. I'm trying to relate it back to that. And so that's what you would use to find your answer. Okay, let's go through an entire example, and we'll go through a few more in our next lesson. This says, using the weights of the simple random sample of men, we obtained a sample, n is 40, x bar, sample mean 172.55. The weights of these men have a standard deviation of 26, so that's S, standard deviation of the sample. We're testing the claim that the mean weight is greater than 166.3. So my null hypothesis is mu equals 166.3. My alternative is mu greater than 166.3 with a significance level of 0.05 given to me in the question. If they don't tell you a significance level, assume 0.05. I need to find the test statistic. So my sample mean, 172.55 from up here, minus my claim, which is in my null hypothesis, divided by the S over root n. I get a t statistic of 1.5203. If I use the table, I would have to go to degrees of freedom of 39, and I'll find my p-value range. If you go to that, this test statistic is between the 0.5 and 0.1 for the p-value, or area of one tail. It's area of one tail because it's a greater than. Because this is at least 0.05, that means this is higher than the alpha level. The p-value is higher than the alpha level. And if that is the case, I fail to reject the null, and then there is not sufficient evidence to support the claim that the mean weight of men is greater than 166.3. That's one way that you could find that, and you need to be comfortable about showing the p-values in this regard. The other option for finding the p-value would be the technology piece. So I could plug in and say, okay, well, my degrees of freedom is 39. I want a greater than and whatever the test statistic is. And notice I get 0.068. 0.068 is the exact p-value, which is between these two values. Okay, but that's still, either way, I still get the same result, that I'm going to fail to reject the null hypothesis. The method that's on this slide is more of a critical value idea. The method on this slide is more of a p-value idea, and you find the exact p-value to find that answer. You're going to have to be able to kind of mix and match some of both of those for your test and homework questions, so please make sure you're looking at that to be successful. Again, this is when you have sample means and sample standard deviation. You have to use your t-table to find critical value locations and things of that nature, and then using StatCrunch with the t-test in order to find the exact p-value when needed. Have a good day, everyone.